Assalamualaikum warahmatullahi wabarakatuh. My name is Sarah Nur Iman binti Muhammad Hanizal. So today I want to present about coloring material, which are dye and pigment. So what's the function of dye and pigment? Dye and pigment are the main forms of colorants used in various industries. A colorant is a substance that is used to impart color to matter. The main difference between them is dyes are soluble substances that impart color to materials, while pigments are insoluble particles suspended in a medium or binder. Difference between dyes and pigment. Dyes particle is very small, while pigment particles comparatively large. Dye particles are much smaller than pigment particles. Hence, dyes can be affected by UV, whereas pigments are more stable when it comes to UV exposure. This means UV rays cannot break down pigments. Secondly, solubility. Dyes are soluble in many liquids. An example would be like food coloring or sugar and water. If leave sugar in the water, the sugar will eventually dissolve into the water. Dyes dissolve in solvent to stick to fabric and materials, while pigments are insoluble in water and most solvent. An example would be carbon or mud. If you mix mud in water, it will not dissolve into the water. It will settle below the surface. It consists of ground coloring matter suspended in liquid, which forms a paint film that actually bonds to the surface it is applied to. The resistance is higher and the size is larger than dyes. Next is type of compound. Dyes is organic compound and pigments are inorganic or organic compound. Other than that, binding agent. Dyes does not require binding agents because dyes create functional group bonds between dye and substrate. Compared to pigment, pigment requires binding agent because in pigment, functional groups do not bond and typically need a binder. Furthermore, dyes have a direct affinity to textile, while pigments have no direct affinity to textile. Therefore, dyes diffuse in the fabric, while the pigment diffuse on the fabric. Moreover, longevity factor for dyes is vulnerable to fading, while pigments resistant against fading. Last but not least, dyes are costly compared to pigment. Next, we move to the type of dyes. Firstly is acid dyes, water-soluble and ionic dyes that are applied to fibers such as silk, wool, nylon and modified acrylic fibers using neutral to acid dye baths. Moreover, sulfur dyes. Sulfur dyes provide very deep shades which have excellent resistance to washing but poor resistance to sunlight. They will dye cotton, linen and rayon, but not brightly. Last but not least, azoic dyes. These dyes used primarily for bright red shades in dyeing and printing. There are two types of pigments. First is organic pigments and inorganic pigments. Organic pigments such as azopigments, diazopigments, quinacridone pigments, and polycyclic pigments. While for inorganic pigments such as carbon black, chromium oxide green, cadmium yellow, and ultramarine blue. Difference between organic and inorganic pigments. First is chemical composition. For organic pigments, it contains carbon-hydrogen bonds and are often derived from living organisms or synthesized carbon-based compounds. For inorganic pigments lack these carbon-hydrogen bonds and are composed of metallic or mineral elements. For color range, organic pigments is vibrant and intense color, while inorganic pigments is variety of colors, but they may not be as vivid. Next, stability. Organic pigments are more prone to fading under certain conditions, while inorganic pigments are more stable and resistant to environmental factors like light, and heat. Last but not least, application. In application for organic pigment is where color brilliance is crucial, such as in textile and plastic. While for inorganic pigments, application requiring durability and resistance to fading, such as in agricultural coating and paints. Last but not least, case study. Introduction. Anthocyanin pigments is one of natural pigments material. Pigments are present in each one of the organisms in the world, and plants are the principal producers. There are in leaves, fruits, vegetables, and flowers. Anthocyanin pigment was prepared from charcoal by filtration method. It was added to natural rubber from 5 pphr to 25 pphr. The samples with anthocyanin and without were exposed to UV for a various periods, and some mechanical and physical tests were carried out for the prepared specimens. The objective of this case study is to study the effect of anthocyanin pigments on protection of natural rubber from UV radiation and effect of pigment on some physical and mechanical behaviors of natural rubber. Figure 1 and 2 show the effect of pigment percent on the tensile strength and modulus of elasticity of natural rubber. It can be seen that the tensile strength and modulus of elasticity for the composite slump with increasing pigment percent. This behavior may be attributed to work of the anthocyanin pigments as a plasticizer that lead to weak of intermolecular interaction forces. So the rubber chains slide one to another. Therefore, tensile strength and modulus of elasticity decrease. When samples were subjected to UV for 2 weeks, a slight improvement feature of tensile strength and modulus of elasticity happened compared to the corresponding value in case of absence of exposure to UV radiation. This is due to create the free radicals in the rubber chain by UV, which break some bonds near the surface and work these roots to form a new percent of cross links between rubber chains, causing improvement in tensile strength and modulus of elasticity. But when samples were subjected to UV for a longer period, and a result of the large number of entanglements lead to contraction of sample and generating of cracks. These cracks are superabounding with increasing duration of exposure to UV. The tensile strength and modulus of elasticity were reduced. But we note that the rate of decreasing of tensile strength and modulus of elasticity for the sample with anthocyanin pigments was slightly compared with sample not contain anthocyanin. This gives a clear result on the anthocyanin pigment protection of rubber from the degradation by UV because of it absorbed radiation. Figure 3 shows the effect of pigment percent on elongation of natural rubber. It can be seen that the elongation of the composite jumps with increasing pigment percent. At loading apply, the chain slide easily due to the pigment. This is lead to increased elongation. At exposure to UV, the sample become brittle due to entanglements. So the chain become unable to move. Therefore, the elongation is decreased. That's all from me. Thank you.